There's another interesting situation when we try to analyze the size of infinite number sets. But wait, why would I want to know the size of a set of infinite numbers? Isn't the answer infinity? There's actually more to it than that. To start, let's define one notion of the size of a set called its cardinality. That's the measure of the size of the set by counting its elements. For example, I have 5 unique cards in a deck of cards. We can say that it has a cardinality of 5. However, there are sets that also have an infinite number of elements. For example, the set of all natural numbers like 1, 2, 3, 4, etc. Strangely though, infinite sets can have different cardinalities. We will look at a simple example where we demonstrate two possible sizes of infinities, countable and uncountable. The uncountable infinite set is larger than the countable infinite set, meaning it has a larger cardinality. In order for two countable infinite sets to have the same cardinality, or the same size, we need to arrange their elements in a list and demonstrate a one-to-one relationship between the elements of the two sets. For example, we can take the natural numbers, 1, 2, 3, 4, 5, etc., and compare them to the set of integers. Now, you might be tempted to say that the integer set is 2 times bigger than the natural number set, but remember, these are infinite sets, so saying 2 times infinity compared to infinity doesn't make sense. Instead, let's rearrange the integers side by side with the natural numbers. Notice that we can create a one-to-one mapping between the natural numbers and integers. Since every number in the integer set has a corresponding number in the natural number set, then we have shown that the two sets have the same cardinality, the same size. What about the rational numbers, numbers that can be any kind of fraction of integers? Strangely, the rational set of numbers is also countable and the same size as the integers and natural numbers. However, it turns out that the set of all real numbers is uncountable. The set of real numbers is larger than the infinite countable sets like integers and rational numbers. Countable sets are actually the smallest infinite sets. Technically, there are also different uncountable sets with different cardinalities, but we won't go into that here.